Hi everybody, welcome to another Fixxup. So some of you might have noticed that we didn't have a live broadcast last week, so that was due to technical difficulties. So I thought it would be nice to make a video that will contain all the nice features that we talked about in the new .NET framework. My name is Fani Reinders. I am a .NET MVP, and today I'm here to talk about the next generation open ecosystem from Microsoft called .NET 2015. So before we jump in, I would like to share some feedback that Microsoft got from their customers, being the developers out there. Every company is becoming a software company these days. Having said that, this makes the developer role extremely important. So companies need to innovate and deliver faster. Having said that, there is a massive trend in cross-device development strategy, meaning apps need to run on every platform and on every device. There is a rapid innovation in the open source world, which enriches the platform and community. And of course, compatibility to existing apps that run the business need to evolve. So there is a need for a framework that will allow us to support existing apps, but also be robust enough to enrich existing solutions to be upgradable for the future. With that in mind, Microsoft created a roadmap with three common themes. Number one being the .NET innovation. They literally went and modernized every layer of the platform to bring it forward, being the compilers, base class libraries, app models, runtimes, and tools and languages. They've also started to embrace the open source movement by having their engineering process completely out in the open. And lastly, cross-platform. Their customers are also operating on other platforms like Mac and Linux, and they would like to extend the .NET framework not just for having to run on Windows only, but also to be able to run on platforms like Linux and Mac. So this next slide is a 10,000 foot view of the .NET framework. And if we move our attention to the bottom, we see there are all the shared stuff that the framework depends on. There are the runtime components that includes the next generation JIT, the ReuJIT, single instruction multiple data module, and also the new garbage collector. It also includes a collection of NuGet packages and also the base class libraries for the full framework and the .NET Core framework. And lastly, we have the compilers, which include various languages like C# 6, VB 14, and F#, as well as the .NET compiler platform, which is a fancy word for Roslyn that we all know. Moving up on the stack, we get the .NET Framework 4.6. Now that is basically the full .NET framework like we know it today, including more additional features that will allow us to cross over from the old .NET to the new .NET Core. So the full framework 4.6 is a highly compatible in-place replacement for the older versions of .NET, being version 4 to 4.5.2. It also has a full support for of any .NET API and libraries in the market. It uses a WPF as the platform of choice, and ASP.NET 5 is also supported out of the box. .NET 4.6 also invests in the new compilers, the JIT and language innovations that the new .NET framework have to offer. So .NET Framework 4.6, also known as the .NET Full Framework, will be the framework for the app models that we know today, which are WPF, WinForms, and ASP.NET, and will only run on the Windows platform. But when we move our attention to the right, at .NET Core 5, we see a glimpse of what we can expect to come in the future. Currently, it supports two main components. The Core COR, which runs on Windows, Linux, and Mac, and .NET Native, which currently just run on Windows. So currently, the Core runtime is used for ASP.NET 5, and .NET Native runtime is used for universal Windows apps. The whole .NET Core framework is modular and optimized, and everything is delivered by NuGet. While I was preparing for this presentation, I was looking for a slide to accurately show the difference between .NET Core and the full .NET framework. And luckily I came across a image sourced from Twitter at Wardbell, which actually, funny enough, shows it very accurately, the .NET Core and .NET Framework. So here we can actually see that the .NET Core is a subset of the .NET Framework, but in the future it will basically include the same features and even more of the full .NET Framework. One thing to note is that the APIs for the .NET Core base class libraries is identical for the different app models, ASP.NET 5 and Universal Windows apps. They don't just look the same, they are the same implementation. So let's quickly talk about the difference on touch and multi-touch, as well as HTTPI, scrolling and virtualization improvements. Blend is now built into Visual Studio 2015, and it also makes use of the new language service based on Roslyn. And last but not least, there are plenty of new shiny UI debugging tools for XAML available. Alright, so let's quickly jump into a demo. I've got Visual Studio 2015 RTM open with a sample WPF application, and yeah, it is showcasing my brilliant UI skills with a form with 3 buttons, purple, green and red button. And when we go ahead and run this guy, we would immediately see that the new feature on Visual Studio, the diagnostic tools, are firing up very nicely, showing us stats on memory usage and CPU utilization. Now this is an overall Visual Studio IDE feature, not necessarily specific to WPF. But what is specific to WPF is the live visual tree explorer. So I'm just going to quickly go ahead and dock this to the right, and we have our running application to the left and Visual Studio on the right. So when we open up the visual tree window, we can click the enable selection button on the left. Now that enables us to select certain elements on our form. So let's say there's something wrong with the red button. It's not quite red, it should be yellow, for instance. We can click on the button, and immediately it will show us in the hierarchy where that element lives. Now that's not all. We can even go to the live property explorer, and we can go change the values live on the fly. So for instance, make the content hello world. We can make the background color, make it yellow, etc. And there we go. This is just some of the brilliant features they've brought out for WPF, showing us how to quickly, during runtime, debug our WPF application and change runtime values. One of the other more exciting features of .NET is the .NET compiler platform, or in other words, Roslyn. Microsoft invested very much in creating a newer, modern platform for compilation, which transitions it from the old compiler models where compilers were isolated and closed and very hard to extend, transitioning them to a more open platform with rich extendable APIs that will allow developers to create awesome diagnostic tools like code analysis and code fix providers, as well as custom diagnostics in the code. Okay, so let's quickly see how easy it is to create a custom analyzer that would scan our code for defects due to conventions. I've got a little test analyzer project open just to show you how easy it is to create it. When we go to a file, new project, under the extensibility section, you can see all the extensibility templates. I just went ahead and did the analyzer with code fix, NuGet and physics project template. That should that should get you started in no time. So my code analyzer, all it basically does, it checks if the interface names start with I, because interface names can be written without a prefix with an I, and I just personally um, like to prefix all my interfaces with a I character. So this analyzer, what it does, it will check for the interfaces if it's prefixed with I, and if it doesn't prefix with I, it will give you an actual warning. Having said that, an analyzer also comes with a code fix provider that will allow you to fix your code accordingly, so that that warning can go away. So let's quickly go into the interface analyzer. So this is very simple. I've got my new rule set up that will basically state that the title is invalid name for interface, and the description should be this interface name should start with I, and it should fall under the naming category. So on the analyze symbol void method, I grab my name symbol and I just basically do a type kind check. So if the type is an interface and the name of the type does not start with I, then I would like to create a new rule that is based of my diagnostic descriptor I've created above. I want to create that new rule that will start lighting it up in my code. Having said that, when we go back to the code fix provider, so this is the code fix provider that we can use to alter our code if the rules does not pass. So here I basically say the code fix provider should say the title should be prefix and interface with an I, and it basically does a bunch of stuff. One of being it in the context, it will register a code fix which will call my prefix interface async function. Now all that basically does, it will get the original name and prefix I towards it, and that is it. So to quickly show you guys how that works, we can basically build it. Right click, build it. You can also run this as a visx, but I want to show you how to deliver your code fix and your analyzer via NuGet. So I already built this thing. I've got the latest version of the NuGet package available. So that happens every time you build it, it should create a NuGet package for you on the fly. I'm just copying it to my little local NuGet folder over there. And I want to fire off a new instance of Visual Studio to make sure everything is going according to plan. Go File, New Project. Oops. Go File, New Project. And let's just create a class library and call it Fixxup. Alright, so let's get rid of this class. So you might know that if you create a normal interface, you can call the interface, for instance, foo, and nothing will change, which is totally acceptable. But I normally like to prefix my interfaces with an I, and Roslyn actually gives us a very nice way of doing this. So to add our NuGet package, we literally go right click, manage NuGet packages, and here you also see the new layout for the new NuGet that comes with Visual Studio 2015. It looks totally different. They've redesigned it from the scratch. So I just picked my source to be local, and I literally say install this test analyzer into my project, and it should work. Once that's done, I can close, and then I wait. And after a few seconds, I immediately see that I get a green squiggly at my interface name. So when I hover over it, it will say interface name should start with I. And you can also see the little light bulb there, similar to the resharper. Now when we click that little light bulb, it actually tells us we can prefix our interface with an I, showing us a code preview what will be done. You can also click on the actual type and hit Control dot, which will do the same thing. So we can go prefix with an I, yes I would like to do that, and and it will take the rest of the stuff forward, asking you to refactor even further. That's just one of the small features that you can do using Roslyn. Alright, so let's quickly talk about the Universal Windows Platform. Microsoft now created one Windows platform, allowing us to write our application once and deploy it to any Windows platform, being it a Raspberry Pi or a Xbox, Windows PC, phone, or even the HoloLens. One application with a seamless UI responsiveness to solve our cross-platform problem. Now, to do that, we need a runtime called the .NET Native Runtime that we already spoke about. Currently, it's only supported on Windows for now, but the .NET Native Runtime is basically the next generation compiler for store apps. It includes a lean runtime and C++ optimizer, allowing us to do C# apps with the C++ kind of performance. And it allows us to execute our application much faster with a reduced memory footprint. And even better is you can use your existing app or even a new app, but just by compiling it in release mode, it will have an automatic increase of about 60% performance startup time, which is quite impressive. Okay, now that we know the features of the client-side application world, let's shift our mind back to the server, where we have ASP.NET 5. Now, ASP.NET 5 is built on top of .NET Core. It is completely cloud-ready with a leaner, faster, and simpler model that is redesigned from the ground up to be ready for cloud and cross-platform. The design is modular and open, which allows us to be more flexible with the open source world and a modular implementation. And it also includes improved tooling and frameworks that we can deliver our solutions faster. Now, if we're going to be doing ASP.NET 5 apps, we need to understand a bit more about the runtime. There are three core components that we need to wrap our head around to make the understanding a bit easier for us. So number one, we have DNVM, which stands for the .NET Version Manager, and it's basically the version manager tool for all our packages. Next, we have DNX, which is the .NET Execution Environment. It's basically an SDK, and different versions are available for the .NET Full Framework, .NET Core, and Mono. Thirdly, we have DNU, which is the .NET Utilities, and it includes functionality to restore our packages and basically uses NuGet at the background. Alright, let's quickly show you guys how to do a ASP.NET 5 application. First of all, it's a very good read to go to docs.asp.net, where you can find all the relevant documentation, for instance how to install it on Windows. You can go through it and see how to install DNVM and the DNX. I've done that already, but let me quickly show you on the command prompt what do I mean. Okay, so from the command prompt, after installing the DNVM, using that PowerShell script, it allows you to create a call to DNVM like a DNVM and then list. That will show you all the runtimes that's available and installed on my profile. As you can see, I've got the full framework CLR and I've got the core CLR. Now to get more information on DNVM and other commands, we go DNVM and it will show you all the commands available. To install a new version of a runtime, we simply go DNVM install latest, and that will go and grab the latest version of the runtime of the applicable operating system and install it into our profile. In this case, it installed the DNX full CLR, but you can also default to the core CLR by passing in the R switch and specifying core CLR. Doing that will install the core CLR version of the runtime. Okay, so let's go back to Visual Studio. I've got Visual Studio Code open, and as you can see, I have a empty Visual Studio Code. I'm going to do this in Visual Studio Code just to show you how possible it is to create an ASP.NET 5 solution outside of the conventional Visual Studio IDE. You can use any text editor you want. I just chose to use Visual Studio Code. So what we have here is an empty Visual Studio Code. What we need to do is first of all create a project.json file. Now in there, because it's a JSON file, we need to have a version, and see how Visual Studio Code gives us that IntelliSense, which is quite cool. And I can also go ahead and say which frameworks I want to target. In this case, I am want to target the .NET Core, so I will say DNX Core 5.0, and I will leave the dependencies open for now. But just to also prove a point here, that you can specify more than one framework. For instance, you can say DNX 451, and it will go ahead and compile it for the full framework as well. But in this case, we just want to be able to compile for the .NET Core. I'm going to go ahead and add a dependency on system console. So I'm going to type system.console, and as I type this, Visual Studio Code gives me nice IntelliSense on the NuGet packages available. So in this case, I'm happy to use that version there. Save this, and now it says me, okay, I've got some unresolved packages or dependencies from the project.json file, and we need to go and restore that. So what I normally do is I go back to my command prompt, and I use the DNU utility to say restore, and that will go ahead and restore my packages that I've specified. Now when I go create a new class, I should be able to use a normal C# syntax like system, public class program, and also have a public void main, which accepts a string array of args, a typical console application. And then I can go console.writeLine, and I love the IntelliSense it gives me. When I do that, I can, well, I first of all need a read key, read line. When I do that, I can go back to my command prompt, and then I can say dnx current directory dot and run. When I run that, it will run hello. This might not be significant, but it is awesome source. Okay, so let's modify our application a bit to do some cool stuff. First of all, that we might need is another dependency on top of the extensions of the system.runtime. So I'll have system.runtime extensions. I'll just use that version there, and I'll go ahead and say using system.runtime in there. Okay, so now we can start modifying this program, but before I need to go on, I need to restore the packages. So I can go do new restore, restores the extensions. Then I can start using it by typing a variable name. OS name equals a environment get current environment variable. I want to get the OS, and then I'm simply going to say console.writeLine, and I'm here going to use the C# 6 functionality because it's baked in Visual Studio Code. I am running on whatever OS I'm using. This is called string interpolation. I'll get to that in a second. And then I'm going to make use of a sort of a greeter class that will print out nice ASCII art for me. I've pre-prepared some code that will allow me to do just that. Dragging it in. There we go. And then by simply just using it, I can so then I say var greeter equals new greeter. That's obviously looking for a reference. Going back, do the same thing, do new restore, go back there again, and then I can create a new instance of the greeter class. Then I can use the greeter class to say I want to be able to greet on the screen. I can pass in a name. Let's say Fani. And then lastly, we'll call console.readline. So that's a mouthful, but let's just see how this works. I save this, then I can go back to my command line, and I can go and run it on the execution environment by yet again specifying dnx, current directory, and run. And there you have it. Nice ASCII code saying I'm running on Windows, hello Fani, and some custom code that is executed. So let's get this running on Linux. So I've got a PuTTY window open, and I have a copy of this code on GitHub. There's the URL if you want to go check it out. I'm just going to clone that into my folder. Now this PuTTY window is running on a Ubuntu 15 machine. So I'm going to cd into that and show you what I have there. I've got a greeter, I've got a program, I've got a project.json. Now let's see what runtimes are installed on here. As we can see, I've typed dnvm list, and it's showing us there are 3 runtimes installed, beta 7 and the stable beta 5, which is currently using the mono runtime. So in this case I will demo the mono runtime, but it can also run on the core CLR runtime on top of Linux. So the same thing, we just then go dnu restore. It will go ahead and fetch all the packages it needs to run this application. And when it's done, let me just clear the screen a bit, then I can physically go ahead and execute it. So I say dnx the current directory and type in run. Now this version I've created ability to pass in a parameter. In this case I'm just passing in Fani. When I run it, and hopefully we will see something happening. There we go, we see the Fixxup logo, and like we see now on the screen, it is running on Unix. So if we've got Windows and we've got Unix running at the same code and using the .NET core. Okay, so we are back in Visual Studio 2015, and I would like to talk a little bit about the new C# 6 features that has been released and that is ready for us to use. I'm not going to go through all of them. I'm just going to go through a select of them. So first of all, we have auto property enhancements, meaning if we have a class called myClass and we have a property myProperty, normally what we have a constructor, and then we normally say myProperty equals a value. But now with the auto initializers for this property, we can get rid of that and initialize it in here, which is quite cool. And the same goes for getter only properties. So if you have a private set, you can do that, and it will have a read-only property and assign it initially to 100. We call this getter only auto properties. Another feature that is quite cool is the using static import function. So let's say we have a constructor, and normally when we want to write something out to the console, we say console.writeLine blah. It can become quite tedious to all the time write console the whole time. So now the using static allows us to go using static, specifying the static class system.console, then which makes this irrelevant. So we can go ahead and simplify that. Now we can just write writeLine, and it will automatically pull in system console at each call. Moving on to the next one, null conditional operators. So let's say we have a different class. We call it person, for instance, and this person has a name. And if we want to use that person, we can go ahead and say person is P, and if we say, for instance, writeLine whatever the value .p name is, it will most likely fail because P is unassigned. So if we unassign that, for instance, to null, it will compile, it will work, but during runtime we will get a null reference exception. Now the null conditional operator is a little question mark, which allows us to do the whole if null then that check. For instance, it will go and do this if p equals null check and handle it accordingly. When it reaches a null, it will just stop execution and go on to the next line, which is quite cool. One of my personal favorites are string interpolation. For instance, if I have a string, I can go ahead and use the $sign to type in hello, and then all of a sudden I can use one, and I can say, for instance, I have a name which is Fani, and instead of saying one, I can go and say name. So that will print out hello Fani, which makes the readability much better. Okay, so lastly, let's talk about exception filters. Something that VB and F# have is the exception filters. Now C# also has them as well. So now if we have a try catch block in the exception, where we have exception EX, we can actually check whether this exception is a certain condition. So we're using the when clause to check whether something in the exception, for instance the data or something, is a certain condition, and then only catch it on that conditions. So this is just some of the features in C#6 that is new and available, and I urge you guys to go and check it out and use it, because Visual Studio 2015 is available and good to go. Okay, so now wrapping up, This is everything that is open sourced right at this moment. We have ASP.NET 4 and 5, we've got the core CLR, we've got all the runtime components, we've got the .NET compiler platform Roslyn, C#, VB and F#, and the .NET Core 5 libraries. I must also add that the full framework is not open source, but it's rather source open. Meaning you can go to referencesource.microsoft.com and check it out. But they're not accepting any pull requests or anything like that. So that is it. They urge you to go and send pull requests to the items that are listed here. Go ahead and do some contributions, and it would be quite awesome to get involved in the community. That brings us to the end of this presentation. Like I said, my name is Fani Reinders. I would like to thank you for watching. If you have any comments or questions, do feel free to reach out. There are my details. My website is reinders.co. I'm also available on Twitter at Fani Reinders. And yeah, if you do want to go check out .NET on GitHub, just go to github.com/.net. And also to get Visual Studio, you go to visualstudio.com. Thank you very much for watching, and until next time.